Chapter 1.3. In this chapter, we're going to cover the formulas for distance and midpoints. The first formula will be the distance formula for 2 points on the number line. And for these 2 points, we're going to subtract the 2 points and take the absolute value. So it doesn't really matter if you do x1 minus x2 or x2 minus x1. So it's the absolute value of the difference between the 2 points. The distance formula in the coordinate plane is derived from the Pythagorean theorem. And here to do that, the distance PQ would be the square root of the differences in the x's squared plus the differences in the y squared. So for problem A, we're asked to find the distance of QR. So QR would be the absolute value of the difference between the 2 points. So -6 minus a -3, which is the absolute value of -6 plus 3, which is the absolute value of -3. So the distance QR is 3. For problem B, we're asked to find the distance between the point E, which is -4, 1, and the point F, which is 3, -1. They want us to show our work, give the exact answer rounded, and the answer rounded to the nearest tenth. So looking at EF, it's the square root of the differences in the x's, so -4 and 3, -4 minus 3 squared, plus the difference in the x's, plus the difference in the y's, which would be 1 minus a -1 squared, which would be -7 squared plus 2 squared, 49 plus 4, which is rad 53. So the exact answer is EF equals rad 53 units. This is the exact answer. The rounded answer is if we had plugged that into the calculator, we would get 7.3 units. And notice I use the approximate sign. So this is the rounded answer. What I really want you to note is that if I put in the calculator, I get quite a few decimals. And if I copy all those decimals down, this is not an exact answer because the decimals would go on forever. Now if I graphed it, E would be -4, 1, and F would be 3, -1. And if I drew a triangle, a right triangle, let's call this point here X, the length of EX would be 1, 2. The length of XF would be 1, 2, 3, 4, 5, 6, 7. So EF squared would equal 2 squared plus 7 squared by the Pythagorean theorem. EF squared would be 4 plus 49. So EF squared would be 53. So EF would equal plus or minus rad 53. And we checked our answer. We can always do it by the Pythagorean theorem, and that is really how we came up with this formula. The midpoint formula on a number line is the average of the 2 points. So it'd be x1 plus x2 divided by 2, and it gives us a new point, which is m, the midpoint. It's the same when we look at the number line. It's the average of the x's and the average of the y's. So remember that this is going to be a point xy is going to be our midpoint. So if we look at this, the x part is going to be the average of the x's, comma, average of the y's. So the midpoint is an actual point, xy. To get the x-coordinates, it's x1 plus x2 divided by 2. To get the y-coordinates, y1 plus y2 divided by 2. In problem C, the temperature on the thermometer dropped from a reading of 25 degrees to 8 degrees. Find the midpoint of these temperatures. So we have a number line where it's negative 8, 25, 0 somewhere in between, and we want to find the midpoint. 25 plus negative 8 divided by 2 gives us 8.5 degrees. To find the coordinates of the midpoint of G, which is 8, negative 6, and H, negative 4, 10, we find the average of the x's, and the average of the y's. This is 4 divided by 2, and 4 divided by 2, which gives us that the midpoint is 2, 2. The form of the midpoint, again, is always going to be written as a coordinate, an x and a y. Graphing it, we have that G was 8, negative 6. This is G, which is 8, negative 6. And H was negative 4, 10. Joining those 2 points. And then we have that the midpoint was 2, 2. The next problem is a backwards problem. We want to find the coordinates of the missing endpoint if E is the midpoint of DF. So we have D is one of the D is one of the endpoints, E is the midpoint, and F is another one of the endpoints. So we have that D is negative 3, 4. We have that E is 2, negative 5. And this is a midpoint. And we have that F is xy, which is unknown. So setting it up in the form that we know that the midpoint is 2, -5, and that equals the average of the x's and the average of the y's. So we know that this 2 corresponds, so 2 equals -3 plus x divided by 2. The 5 corresponds to the y portion. So -5 equals 4 plus y divided by 2. Solving the first one, 2 equals -3 plus x divided by 2. Multiply both sides by 2. I have 4 equals -3 plus x. So I have that 7 equals x. Solving the second one, -5 equals 4 plus y divided by 2. Multiply both sides by 2. I have -10 equals 4 plus y. So -14 equals y. So I have that the point F is 7, -14. Graphing it, I have that D, which was one of the endpoints, was -3, 4. So -3, 4. This was D. And I had the midpoint was 2, -5. And then the next point I had was 7, -14. Which is approximately there. And I can join these 3 points into a segment. That concludes lesson 1-3.